if the highest common factor of two numbers is 1, then the numbers are said to be co-prime. For example, 7 and 15 if you take. Okay. So these two numbers are co-prime. Why? Just because 7 is prime? No. Their highest common factor, the largest number that can divide both the number is 1. That is why. Likewise, 8 and 9, are they co-prime? Consecutive integers always co-prime. Okay. Likewise, take these numbers 8 and 15. Whether why I am giving these many examples means co-prime means you should not confuse that with the prime numbers. Okay. So here 7 is prime, 15 is not prime, but both together is co-prime. Like here 8 is also not prime, 9 is also not prime. 7, what is that 8 and 9? Are they prime numbers or composite numbers? 8 is a prime number or not? Composite. 9 is also composite number. So two composite numbers, but both together, how we are calling it? It is co-prime. Okay, that is it. Likewise, here 8 and 15, they both are not consecutive, not prime numbers, but both together is co-prime numbers. Got it? So using these details, we are going to prove a particular number is an irrational number. In short, irrational number means non-terminating, non-repeating decimal will come, okay, and then square root of a non-perfect square number will come. Third, like we heard just before, right? Third. So if we can't take this number out of the square root means we call that is irrational, simply. Okay. Shall you say, can you say root 9 is irrational? Okay, root is there. 9 is a perfect square. Okay. So in short, how we can put all this together means, if P is prime, then root P is irrational. Okay. P is prime, then root P is irrational. That's all. Now, shall we prove root 2 is irrational? We already discussed these things, remember? So we are going to prove that root 2 is irrational number. Prove that root 2 is irrational. So we are going to proceed the proof with assuming the contrary. Okay. So we assume that, let us assume that root 2 is rational. Okay. Rational means then we can write this root 2 as in the form of a by b, where a and b are integers and co-prime. Okay, they are integers and co-prime. Co-prime means it is in the simplest form of the fraction. Okay, now cross multiply and simplify. Now what you are going to prove is these numbers are not co-prime. Then this cannot be the rational number. That is what we are going to prove. Okay, suppose this root 2 is a rational number means this a and b must be co-prime. If this co-prime factor breaks means it's not co-prime. So what breaks this one? What is the definition of co-prime? We have two numbers. Their HCF is 1. If we can able to prove a number other than 1 is a factor for them, both of the numbers, then we say the co-prime factor broken. Okay, we want to make it really fast. We'll just cross multiply these things. We have b into root 2 is equals to a. Now square on both sides. When we square on both sides, here we have b square is equals to b square into 2 is equals to a. Now what do you observe here is, a square. Okay. What do you observe here is a square is a multiple of 2. Is it? Is it or not? A square is 2 into some number. Whenever number is 2 into something, it's a multiple of 2. Okay. Then from this 2, shall we say 2 divides a square? Meaning what? If it is a multiple of 2, it can be divisible by 2 also. Okay. So 2 divides a square. Also there is a theorem in our book that since by the theorem, if p divides a square, then p also divides a. Because technically 2 divides a square means it's a product of 2 a's. Is it? Which means each a can be divisible by 2. That is what it is. So 2 divides a square, and from this theorem we can say 2 divides a. We'll make it as equation number 1. Okay. When 2 divides a, here a is a multiple of 2. Isn't it? What multiple of 2? Could be any multiple. Okay. Then we are going to say a is equals to 2c. Why 2c? 2 divides a, no? Then a should be a multiple of 2. What multiple we don't know. For some multiple c. Like it may be 8, 10 also. If it is 8 means 2 into 4. If it is 10 means 2 into 5. That 2 into what number we don't know. That multiple you are taking it is c. Where c is non-zero real constant. Non-zero real number. Okay. Now substitute this in the equation. We make it a star, whatever. Okay. So then from this star equation, b square 2 is equals to 2c whole square. What I did? Instead of a, I substituted 2c. Okay. Okay, camera angle is changing. New frame, new shot. Good. And then do it like b square into 2 is equals to 4c square. Then cancel these things out. We may get b square is equals to 2c square. Okay. Initially, what was our focus? A and b. Here, a we focus. A is a multiple of 2 we got. Now look at here. Who is a multiple of whom? Is that c is a multiple of 2 or b is a multiple of 2? This b square is a multiple of 2. Is it? Then what we can say? 2 divides b square. Shall we say? Then 2 also divides b. This is a equation 2. Wait a minute. Something is happening. Okay. A and B are co-prime, we said. Which means they have 1 as their common factor, no other numbers. But look at what happened. 2 divides A. 2 is a factor for A. The same 2 is a factor for B also. Okay. Isn't it breaking the fact that A and B are co-prime? This 1 and 2 contradicts the fact that A and B are co-prime. Okay, this cannot be wrong, what we done. Then what could be wrong? Our initial assumption could be wrong. So then, therefore, not therefore. that implies that A and B are not co-prime. So which is a contradiction to our assumption that root 2 contradiction to our assumption. That's all. What is our assumption? We assumed that root 2 is rational. That is because that is why we got this contradiction. So therefore root 2 is irrational. That is it. There comes the proof. Okay. See, this is a standard format. Whatever the number you put in this format, exactly this is the concept. The walkthrough of the proof is, you just assume the given number as rational, as A by B, some people may say P by Q, whatever, based on their alphabet, their numerology. So here, numerology doesn't come under alphabet, right? It will come. So here, this like we'll do, and then cross multiply, and then square on both sides. One number will be a multiple of that given number, then that particular number divides the square of a number, so is the number itself, and then we move on by applying some definition about this multiple. If 2 divides A means A is a multiple of 2, so A is equal to C, like we substitute again, and then we proceed with the proof. Okay, this is the standard form of the proof. Same way, can you guess how to prove root 3 is irrational? Root 3 is irrational. How we can prove this? Same way. Instead of root 2, 3. Here, root 3 is equal to A by B. B into root 3 is equal to A. B square into 3 is equal to A square. 3 divides A square. 3 divides A. A is equal to 3C. Wherever 2 is there, you replace 3. That's all. Okay. But the point is, this structure should not be breaking. Got it? Come on, finish writing fast. And then you try using a number root 2, root 5 and root 7 sometimes.